Hey, how you doing? Seb here from... you already know who I am. And if you don't, check out my previous videos. So this is a little halfway episode to show you all what I've been working on over the past week or so. What I'm calling episode 1.5, A Vision of the Future. As you can see, my head is also kind of a halfway episode. I was finally able to get a haircut, but because of COVID restrictions, I couldn't get a beard trim. So at the moment, I kind of look like a well-groomed caveman. I mean, just look at this shit. These are massive right now. Ugh. I think I'm just gonna have to learn how to cut my own beard, let's be honest. Behind me, I have quite a few proof of concept modules that I've been putting together. And I've been testing it out with a whole machine, and I've basically been able to create my very first DAWless jam. We'll do a bit of a basic patch and module walkthrough soon. But first, let's have a listen to what I've been able to make. So it's a pretty lo-fi beat. Don't know if it's something you could really relax or study to, but dance for sure. I also just had to show off all the flashing lights in the dark, because this thing is starting to look aesthetic. But this is pretty much my vision of where I want the whole synth to be heading. I want to be able to create music on one big integrated system, kind of like FL Studio, but instead it takes up a whole goddamn room. But I basically just started out playing with a Baby 8 sequencer circuit, well, a Baby 4 in my case, and basically just kept expanding on what it could do. So let's take a close up down here and go through a quick walkthrough of just what exactly is going on in this patch. I'm going to be pretty light on the nitty-gritty details, just because we'll have dedicated episodes when I make these modules into permanent PCBs. Alright, let's get into it. So we've got quite a lot going on here, but I'll do my best to try and break it all down for you. But working from top to bottom on this side first, we first have the clock, which is kind of like a metronome keeping everything in the patch in time with one another. So we basically have 3 555 timers, all working in different modes. We first have a free running oscillator, creating the clock pulses, which is basically just a square wave, and we can adjust its speed from pretty slow up to really fast. which you can see is indicated by the LED over here, and also the sequencer lights going along. We then have another 555 timer where we can create manual clock pulses with the press of a button, which isn't doing anything at the moment because we then have another 555 timer connected to a switch and then to a multiplexer chip. So we can select between the free running mode or the manual mode. So if I flick this switch across, we can now see this LED down here is turned on, but every time I press the button, we create a manual clock pulse. We can see this LED turns on, and then the sequence moves on to the next step. This is actually based on a Ben Eater clock circuit, which you can find just up here. I really recommend checking out his channel if you've ever wondered just how computers work at their core. He literally makes an entire 8-bit computer using nothing but breadboards and logic chips. It really is a sight to behold. And while we're on the topic, I also really recommend James Sharman, who's expanded on Ben's computer and now has his computer playing Snake. It's been a mental journey following his content, so definitely check it out. So moving back to my analog computer, the clock is then sending pulses to a 4017 decade counter chip, which has 10 outputs that sequentially turn on every time the chip receives a clock pulse. So you can see where the word sequencer comes from. But since I have limited real estate on these breadboards, I just use 4 of the outputs, enough to make a little melody bassline thing. This circuit is a combination of a Baby 8 and the Music from Outer Space 10-step sequencer. The Baby 8 is stupidly simple, and the MFOS one is, well, pretty freaking complicated. So I just wanted to combine the best parts of both circuits into my own sort of hybrid. The outputs of the chip have multiple connections coming off them. So we have the transistor drivers for the LEDs to indicate which step in the sequence we're on. And then down here, we have some pots to adjust the frequency range on each step, and then also a few diodes down here on selected steps to create a gate signal, which is also indicated by the LED down here. We then have 2 cables coming out from the sequencer. One is the PIP CV output going into the TTO to modulate the frequency, and the other is the gate signal going into the envelope generator. So let's take a listen to the bassline and build up a quick picture of the sequencer. So if I first unmute the mixer, in the clock's free running mode, we can hear the melody being created from the TTO, which is also run through the filter and the VCA. But if I adjust the pots down here, we can change the little melody and the frequency on each step. It's very touchy, so it can just change literally by the wire being moved a little. So now we've created a different sort of melody. I wouldn't exactly say it's musical, but it's something. So let me just quickly unmute this again. So remember the gate signal that I was talking about? We have a gate created on steps 1 and 3 in the sequence. And see how the envelope generator was set to gate mode? It means that we can adjust the envelope being used to modulate the cutoff of the filter in time with the sequence. But if I unmute the mixer, and then change the envelope generator from manual to repeat mode, well, it just kind of all turns to shit, basically. We can get some pretty funky effects if we dial in the attack and decay precisely, but for the most part it sounds pretty terrible. So that's why I included the gate input of the envelope generator, so we can just quickly flick it back, and now it's all back in synchronicity again. And just to show off the manual mode, we can also jump to each step every time we press the button. You'll also hear that if a gate is created on a step, then the generator will rise to its maximum value according to the attack control, and then just stay there, since it's receiving a high gate signal. Then when we jump to the next step, when the gate signal goes low, the generator will fall to its minimum value according to the decay control and stay there. So that's the basic gist of the sequencer. It'll actually be scaled up to an 8 or even 16 step when it comes time to making a full version of the circuit. But that's going to be quite a while away now. So moving on to the other side of this whole mess, over in this top right corner, we first have a clock divider made from a 4013 D-type flip-flop circuit. So this first LED on the left indicates the clock pulse being divided in half. So let me flick the clock back to manual mode. For every 2 presses of the button, we then see this LED turn on and off. 1, 2, 1, 2. We then further divide the half signal into half as well, meaning that for every 4 clock pulses, this LED on the right then turns on. 1, 2, 3, 4. Then coming down to the bottom, we have another LED connected to the output of a 3-input OR gate, which has one input connected to the clock, and another input connected to one of the sequencer outputs, and then the final output just to ground. But this then gives us a little pattern on the output according to the state of the inputs, which is a bit more clear if I flick it back to automatic. 1, 2, 3, 1, 2, 3, 1, 2, 3. But what exactly is the point of this whole division and logic section? Well, that brings me to the other side of the breadboard, where we have 3 808 style drum circuits. These are essentially tunable self-oscillating filters, where we can adjust how close to self-oscillation the filter is with the potentiometer, and then strike or trigger the circuit with a voltage to create a plucky drum sound. We can then use these clock divisions and the logic output to trigger the drum sounds, so that they create a rhythm in time with the rate of the clock. So if I start unmuting our different drums, we can build up a picture of how they work and sound. We have a kick-style drum being triggered every half clock division, so we can create a 4 on the floor rhythm, and we can also adjust the tone of this bass drum. Then we have a snare-style drum being triggered every quarter clock division, giving us a different sound on the 2nd and 4th beats of our rhythm. A tom-style drum is then triggered from the output of the logic chip, giving us a more dynamic sound to add to the mix. This essentially creates a little basic rhythm to mix with the melody from the sequencer. Let's make it a little bit faster. But this isn't the end of it. We also take bass drum sound into the mult and create 2 copies. One is going into the mixer so we can hear its actual sound, but another copy is coming up into the envelope extractor and creating a control voltage out of the kick. This is then taken into the attenuator, where we can invert the CV and then use this to modulate the volume of the melody sound through the VCA. But why on earth would we do this? Well, have you ever heard of a thing called sidechain compression? The often overused ducking sound used to create room in the mix of a dance song and also create a pretty cool effect and sound. So if I now unmute our mix, and if I now flick the VCA back on, we can hear how the melody has its volume pushed down every time the kick drum is triggered, creating the ducking effect, even when I mute the kick on the mixer. Now this only works when we create an inversion of the kick CV, because if I turn the attenuverter back the other way, so that it's an exact positive copy of the kick CV, well, it just doesn't sound good at all. Not for what we're trying to do here anyway. But putting this all together, we've now created a fun little song of sorts, with different elements and sounds that we can bring in and out. This really is electronic music in its purest form. Alright, this really isn't musical at all. Let's stop here. Well, that's all there is for this little video today. I hope you were able to get a bit of a sense on where I'm planning to go with this whole project. The next videos that come out will be about converting all these breadboards into their respective modules, including all the extra features that I'm planning to add along the way. Even the clock itself is going to be pretty off the chain. I'm back to school next week, so I really don't know how much time I'm going to have to shoot these videos. But I'll do my best to keep you all updated. I'm also signed up to a final year project where I'm converting motion into sound, which sounds pretty perfect for me, so I'm keen to see what it's all about when I can get back. If I'm allowed, I might even try and shoot a bit of footage of the whole process to share with you all. And while I'm here, you can also follow me on Instagram at SebCircuitsandSounds, where you can see a bit more of the behind the scenes for these videos. Alright, I'm Seb, this is Circuits and Sounds, and I'll see you next time.